Almost everyone watching this grew up hearing the same advice: never waste food. If there were leftovers from dinner, they became tomorrow's lunch. If there was enough for another meal, it went straight into the refrigerator. It was practical, economical, and in many households, it became a tradition passed down from one generation to the next. Maybe your parents did it, maybe your grandparents did it, and today you probably do exactly the same thing without giving it a second thought. In many ways, it is one of the smartest kitchen habits you can have. But there is one important detail that almost nobody ever explains. The second time you heat that food, you are no longer repeating the same cooking process. You are creating an entirely different chemical reaction. The food may look identical, it may smell the same, it may even taste exactly as you remember, yet inside that pan or bowl, something completely different is happening. In a few specific foods, reheating them the wrong way can create compounds that did not exist when the meal was freshly cooked. Some of these compounds have been studied for decades, and several have even been classified by the World Health Organization's Cancer Research Agency as probable human carcinogens under certain conditions. That sounds alarming, but before you jump to conclusions, let me make one thing absolutely clear. This is not another fear-based message telling you to throw away every leftover in your refrigerator. In fact, the opposite is true. Leftovers are valuable. They save money, reduce waste, and make healthy eating much easier. The real issue is not whether you eat leftovers. It is how you cool them, how you store them, and especially how you heat them again. In most cases, avoiding these unwanted chemical reactions comes down to one simple adjustment on your stove and less than 2 minutes of extra attention. That is all it takes. And before you assume this is another video warning you that microwaves are dangerous, stay with me for just a little longer, because the truth is almost the exact opposite of what many people have been told. By the end of this discussion, you may discover that the microwave is actually one of the safest tools in your kitchen for reheating food, and I will explain exactly why after we go through the science. I'm Dr. John Myers, an internal medicine specialist, and after more than 20 years of caring for patients, I've noticed something interesting. The questions people ask me just before they leave the examination room are rarely about prescriptions. They are usually about everyday habits. They ask about breakfast, coffee, supplements, sleep, exercise, and most often, what happens in the kitchen every single day. They want to know whether certain foods are really healthy, whether common cooking habits are helping or hurting them, and which simple changes actually make a difference over the long term. Those are the conversations that matter, because the choices you make between preparing dinner and cleaning the dishes often influence your future health more than many medications ever could. Tonight, we are going to focus on 4 very common foods. One of them is probably the healthiest item sitting in your refrigerator right now. Another is simmering in kitchens across the country as families prepare dinner. The third is something nearly everyone cooks with every week without giving it much thought. And the last one concerns me the most, because it happens to be the single most frequently reheated food in the world. There is an excellent chance you warmed it up sometime during the last few days. Understanding what happens to these foods during reheating is not about creating fear. It is about giving you knowledge that helps you protect your health without spending more money or changing your entire lifestyle. Before we begin the list, there is one simple principle that makes everything else easier to understand. Once you learn it, you will be able to apply it not only to these 4 foods, but to almost everything sitting in your refrigerator. Think about what happens during the first cooking. Heat performs exactly the job we want it to do. It softens tough fibers, breaks down complex structures, unfolds proteins so your digestive system can process them more efficiently, releases nutrients that would otherwise remain trapped inside the food, and destroys most harmful bacteria. That is why cooking exists in the first place. It transforms raw ingredients into meals that are safer, easier to digest, and often more nutritious. But once the meal has been cooked and begins to cool, the food is no longer the same. The proteins have already changed shape. The starches begin reorganizing into tighter crystalline structures. The fats have already experienced their first exposure to heat and oxygen. Meanwhile, tiny bacterial spores that survived the original cooking process begin waking up if the food remains warm for too long. By the time you place those leftovers back into a frying pan or oven the next day, you are no longer heating fresh food. You are heating food that has already been chemically altered once before. Because the material has changed, the reactions also change. That second round of heat behaves differently from the first, and understanding that difference is the key to everything we will discuss today. The second heating process creates three important problems that the first cooking never produced. The first is that it can create entirely new compounds. These substances were not present in the original ingredients, they were not created during the initial cooking, and they certainly were not there when you first stored the leftovers. They develop only after the food has already gone through one complete cooking cycle and is exposed to heat again under the right conditions. The second problem is that reheating compounds the damage already started during the first cooking. Imagine bending a paperclip. The first bend weakens it. Each additional bend makes it easier to snap. Food behaves in a surprisingly similar way. Proteins, fats, and starches that were already changed by the initial cooking become even more vulnerable during reheating, allowing new chemical reactions to happen faster and more extensively than before. The third issue is perhaps the most misunderstood. Heat is excellent at killing living bacteria, but it cannot destroy every toxin those bacteria may have produced before they died. That means reheating food can give you a false sense of safety. The bacteria themselves may be gone, but certain harmful toxins remain behind, completely unaffected by the temperature. Your meal can smell perfectly normal, look completely safe, and taste exactly as expected, while still containing substances capable of making you seriously ill. Those three ideas, creating new compounds, compounding previous damage, and failing to eliminate certain toxins, form the framework for every food we will discuss. Each one behaves differently, but every example fits somewhere within those three categories. The good news is that every single problem also has a remarkably simple solution, and none of those solutions require expensive equipment, special diets, or throwing perfectly good food into the trash. That final point is worth emphasizing because it is the heart of this entire discussion. I am never going to tell someone living on a fixed income to throw away a perfectly good meal simply because it spent one night in the refrigerator. Food is too valuable for that, and reducing waste matters. The goal is not to stop cooking ahead or preparing leftovers. The goal is to understand the factors that you actually control. You control how quickly food cools after cooking. You control whether it spends hours sitting at room temperature or goes into the refrigerator promptly. You control whether it is blasted over high heat in a dry skillet or gently warmed using a safer method. Those small decisions determine whether unwanted chemical reactions are encouraged or largely prevented. In other words, the real power is not in the food itself, it is in the method you choose. The first food on our list surprises almost everyone because it has one of the healthiest reputations of any ingredient you can buy: spinach, and the entire family of dark leafy greens that includes kale, Swiss chard, beet greens, arugula, and similar vegetables is unquestionably one of the best foods you can eat when it is fresh. Whether you enjoy it raw in a salad or lightly cooked as part of a meal, these vegetables provide impressive amounts of iron, folate, vitamin K, lutein for eye health, fiber, antioxidants, and countless plant compounds that support heart health and help regulate blood pressure. Nutrition experts consistently recommend increasing your intake of leafy greens, and for good reason. They are among the strongest contributors to the health benefits associated with plant-rich diets. Nothing in today's discussion changes that recommendation. I want you eating more leafy greens, not fewer. The concern begins only after they have been cooked, left warm for extended periods, and then reheated. That is when an entirely different chemical process can begin, one that most people have never heard explained. Spinach and other leafy greens naturally absorb nitrate from the soil as they grow. This is completely normal and, by itself, nitrate is not something to fear. In fact, it plays an important role in human health. Your body can convert nitrate into nitric oxide, a molecule that helps relax blood vessels, improve circulation, and support healthy blood pressure. This is one of the reasons vegetables like spinach and beetroot are consistently linked with better cardiovascular health. The problem is not the nitrate itself. The problem begins after the vegetables have been cooked and are allowed to remain warm for too long before refrigeration. During this period, naturally occurring bacteria begin converting nitrate into nitrite. Nitrite is much more chemically reactive, and this conversion happens most rapidly within what food safety experts call the danger zone, roughly between 40 and 140 degrees Fahrenheit. Imagine a pan of cooked spinach sitting on the stove after dinner because everyone is still talking at the table. Or perhaps a spinach casserole remains on the counter while the kitchen is cleaned. During those seemingly harmless hours, bacteria continue working quietly, transforming more nitrate into nitrite without changing the taste, smell, or appearance of the food. Nothing looks unusual, yet the chemistry inside that dish is steadily changing. The next stage occurs when those leftovers are heated again. Once nitrite is exposed to heat in the presence of proteins, it can react with naturally occurring compounds called amines to form nitroso compounds, commonly known as nitrosamines. These chemicals have been studied extensively for decades because of their potential effects on human health. Scientists around the world have investigated how repeated exposure may influence long-term disease risk, particularly cancers affecting the digestive system. The International Agency for Research on Cancer, the Cancer Research Branch of the World Health Organization, reviewed this evidence and concluded that nitrate and nitrite consumed under conditions that promote this internal conversion should be classified as Group 2A, meaning probably carcinogenic to humans under those circumstances. It is important to understand exactly what that classification means. It does not mean spinach is dangerous. It does not mean reheating spinach once guarantees illness. It means researchers have found enough evidence to conclude that repeatedly creating these compounds over many years may contribute to increased cancer risk. The strongest evidence has consistently involved cancers of the stomach, esophagus, and colon, where these compounds have the greatest opportunity to interact with digestive tissues. This is why spinach belongs in what I call the creates category. The potentially harmful compounds were never present in the fresh leaves growing in the field. They were not present when you first cooked the vegetables. They were produced only because of the combination of warm storage followed by reheating. That distinction matters because it shifts the focus away from blaming the food itself and toward understanding the process. Good nutrition should never become a source of unnecessary fear. A single reheated serving of spinach is not a diagnosis. No doctor can look at one meal and predict disease. Cancer develops through countless influences accumulated across many decades, including genetics, lifestyle, environmental exposures, and diet. The contribution from reheated greens is small, but prevention has always been about reducing many small risks whenever practical. That is how meaningful improvements in long-term health are achieved, not through dramatic changes, but through consistent everyday habits that quietly work in your favor year after year. Fortunately, preventing this reaction is incredibly simple. Prepare only the amount of leafy greens you expect to eat during that meal whenever possible. If you do have leftovers, refrigerate them quickly instead of allowing them to remain warm on the counter. The next day, enjoy them cold. Toss leftover spinach into a fresh salad, mix it into a wrap, or add it to a sandwich. You keep all the valuable nutrients while completely avoiding the second heating process that encourages nitrosamine formation. Nothing is wasted, your grocery budget stays intact, and you continue receiving all the health benefits these vegetables provide. The issue has never been eating spinach. The issue has always been reheating spinach after extended warm storage. The second food on today's list may surprise even more people because it appears on dinner tables around the world every single day. Rice is inexpensive, versatile, filling, and one of the most commonly prepared foods on Earth. It also happens to be responsible for thousands of cases of food poisoning every year, not because rice itself is unsafe, but because of the way leftovers are handled after cooking. Unlike many other foods, uncooked rice naturally contains spores from a bacterium called Bacillus cereus. A spore is essentially the bacterium's survival form, protected by a tough outer shell specifically designed to withstand harsh conditions, including the temperatures reached during normal cooking. When rice boils, nearly every other microorganism is destroyed, but these spores survive almost untouched. At first, that may not seem important because the rice has been fully cooked and appears perfectly safe. The real problem begins after the pot is removed from the stove. As the rice slowly cools, especially if it remains at room temperature for several hours, those surviving spores begin to awaken. They germinate, multiply rapidly, and start producing a toxin known as cereulide. This toxin changes everything because, unlike the bacteria that created it, cereulide is remarkably resistant to heat. The following day, you can boil the rice again until every living bacterium has been destroyed, yet the toxin remains completely unaffected. It survives the reheating process and is ready to cause illness as soon as it is eaten. This scenario is so common that emergency physicians have given it an informal name: fried rice syndrome. The classic example involves leftover takeout rice left on the kitchen counter overnight before being fried the next day. By the time symptoms appear, people often assume the reheating should have made the food safe. Unfortunately, once the toxin has formed, reheating cannot reverse the damage. Rice therefore falls squarely into the can't undo category. Heating destroys bacteria, but it cannot eliminate the toxins already left behind. For many healthy younger adults, exposure results in several miserable hours of vomiting, stomach cramps, and diarrhea before recovery. However, for older adults, particularly those over 60, the situation can become much more serious. Aging naturally reduces the body's ability to recover from dehydration, and many people also take medications such as acid reducers or blood pressure drugs that further increase vulnerability. A severe episode of vomiting or diarrhea can quickly lead to dehydration serious enough to require hospitalization. Even repeated mild irritation of the digestive tract over many years is something physicians pay attention to because chronic inflammation plays a role in many gastrointestinal diseases. Rice also presents another, less obvious concern related to reheating. As cooked rice cools, its starches undergo a process known as retrogradation. During this process, starch molecules reorganize into tighter crystalline structures. This change is completely natural and even provides certain nutritional benefits, such as increasing resistant starch. However, when cold rice is reheated in a very hot, dry frying pan, those starches begin browning rapidly. That browning reaction produces a chemical called acrylamide, another compound that has attracted significant attention from health researchers. The International Agency for Research on Cancer classifies acrylamide as a probable human carcinogen, and food safety authorities, including the U.S. Food and Drug Administration, have published recommendations aimed at reducing its formation during food preparation. Once again, the problem is not the rice itself. It is the combination of improper storage followed by aggressive reheating that encourages these unwanted chemical reactions. Thankfully, the solution is straightforward and supported by food safety agencies around the world. After cooking rice, transfer it into shallow containers rather than leaving it in a deep pot where heat remains trapped for hours. Refrigerate it within 1 hour so it cools rapidly and spends as little time as possible in the bacterial danger zone. Eat refrigerated rice within 24 hours whenever possible, and when reheating it, make sure it becomes steaming hot all the way through rather than warm only on the surface. Most importantly, reheat it only once. Once that reheated serving has been eaten, any remaining leftovers should be discarded rather than cooled and reheated again. These simple habits dramatically reduce the risk while allowing you to continue enjoying one of the world's most affordable and nutritious staple foods without unnecessary concern. If you've stayed with me this far, you've probably noticed a pattern. None of the foods we've discussed are unhealthy by nature. Spinach is packed with nutrients. Rice feeds billions of people every day. The real issue has never been the food itself. It has always been what happens after the first meal is over. The way leftovers are cooled, stored, and reheated determines whether you're preserving their benefits or encouraging chemical reactions that work against you. That distinction matters because it means you don't have to spend more money, buy expensive supplements, or completely change the way you eat. In many cases, one small adjustment in your cooking routine can eliminate most of the unnecessary risk. If you appreciate explanations that focus on the science instead of internet myths, take a moment to subscribe and, more importantly, share this information with the person who prepares meals in your household. They're the one who can make changes that benefit everyone sitting around the dinner table. Now let's move to the third item on the list, because this one affects nearly every cooked meal whether you realize it or not. It's not a vegetable or a protein, it's the cooking oil itself. Most households have at least one bottle of vegetable oil sitting beside the stove. Sunflower oil, corn oil, soybean oil, canola blends, and generic vegetable oils are used every day for frying, sautéing, roasting, and reheating leftovers. They are convenient, affordable, and familiar. However, from a chemistry standpoint, many of these oils share one important characteristic. They contain large amounts of polyunsaturated fats. These fats are built with multiple double bonds in their chemical structure. Those double bonds are what make the oils more delicate when exposed to high temperatures. During cooking, especially when heat becomes intense, these bonds begin breaking apart. As they break, they generate a collection of substances known as aldehydes. Scientists have been studying these compounds for many years because several members of this chemical family are associated with cellular damage and long-term health concerns. One aldehyde that almost everyone recognizes is formaldehyde. The International Agency for Research on Cancer classifies formaldehyde as carcinogenic to humans. Another compound that can form when cooking oil is severely overheated is acrolein. If you've ever noticed an old frying pan producing thick smoke with a sharp smell that burns your nose and throat, you've likely experienced acrolein in the air. Researchers have also identified this substance as a probable human carcinogen under certain exposure conditions. These aren't mysterious chemicals found only in laboratories. They are products of overheating fats that many people unknowingly create in their own kitchens. Now comes the part most people never consider. The first time you cook with oil, the damage has already begun. The oil has been exposed to oxygen, high temperatures, and repeated chemical stress. When that same oil is heated again, either because it was saved after frying or because it remains inside yesterday's cooked food, the breakdown accelerates. Researchers at the University of the Basque Country in Spain published important work in the journal Food Chemistry showing that each additional heating cycle produces progressively larger amounts of oxidation products and harmful degradation compounds. In other words, the first heating weakens the oil, and every reheating session pushes it even further. Think of it like repeatedly bending a piece of metal. The first bend changes its structure. Every bend after that causes more damage until it eventually fails. Cooking oils behave in a surprisingly similar way. Once those delicate fatty acids have been altered, they become increasingly unstable every time they're exposed to high temperatures again. This doesn't apply only to people who save used frying oil in a container under the sink. Many families never do that, yet they still reheat oil every day without realizing it. Imagine last night's stir-fry or roasted chicken. The oil used to cook those foods has already soaked into the meat and vegetables. The next evening, those leftovers are tossed into a smoking hot skillet to restore a crispy texture. The oil trapped inside the food now goes through another complete cycle of degradation. Even though you never poured old oil back into the pan, you are effectively reheating the same fats for a second time. This is why simply avoiding reused deep frying oil isn't enough. The cooking method matters just as much as the oil itself. Fortunately, preventing this problem requires only a few simple habits. The first is to stop saving frying oil for future use. While it may seem economical, repeatedly heating the same oil dramatically increases the formation of oxidation products that provide no nutritional benefit and may increase health risks over time. The second habit is to lower the temperature whenever reheating leftovers on the stove. High heat is the driving force behind nearly every unwanted chemical reaction we've discussed today. By using low or medium heat instead of the highest burner setting, you dramatically reduce the rate at which these compounds form. Patience truly becomes one of the healthiest ingredients in your kitchen. The third recommendation involves choosing a more stable cooking fat. Extra virgin olive oil consists primarily of monounsaturated fats, which contain far fewer fragile double bonds than most seed oils. It also naturally contains antioxidants that help protect the oil during cooking. Despite what many people have heard over the years, extra virgin olive oil performs remarkably well for everyday cooking and reheating when used at moderate temperatures. In many situations, it remains significantly more stable than highly processed vegetable oils exposed to the same conditions. That brings us to the fourth and, in my opinion, most important food on today's list: chicken. Along with beef, pork, fish, turkey, and even cooked eggs, chicken represents the world's most frequently reheated source of protein. Think about your own weekly routine. Many families roast a whole chicken or prepare several chicken breasts on Sunday, specifically to provide lunches and dinners for the next several days. Meal preparation has become one of the most practical strategies for saving both time and money. There is absolutely nothing wrong with that approach. The concern lies in how those cooked proteins are reheated afterward. Among all the foods we've discussed today, reheated meat is unique because it can involve every one of the three pathways we've already learned: creating new compounds, compounding previous damage, and failing to eliminate certain bacterial toxins. Understanding these mechanisms doesn't mean avoiding leftovers. It simply means reheating them in a way that minimizes unnecessary chemical changes while preserving both flavor and safety. When meat is cooked over high dry heat, something interesting happens at the surface. Amino acids naturally present in muscle tissue react with creatine, another compound found in meat, producing chemicals called heterocyclic amines, or HCAs. These compounds develop primarily in the browned, grilled, or charred portions of meat, and the hotter and drier the cooking method becomes, the greater the amount that forms. This is why heavily blackened grilled meat contains significantly higher concentrations than gently poached or steamed meat. The National Cancer Institute has published extensive information explaining how HCAs develop and why researchers continue studying them. Laboratory experiments have shown that many HCAs are mutagenic, meaning they are capable of damaging DNA under experimental conditions. Animal studies have also demonstrated their ability to contribute to tumor formation, while several population studies have observed associations between frequent consumption of heavily browned meats and increased risks of cancers involving the colon, pancreas, and prostate. These findings do not prove that eating grilled chicken occasionally causes cancer. Instead, they reinforce the broader principle we've discussed throughout this video. Repeated exposure over many years matters far more than any single meal. As we wrap up, remember that this video isn't about fearing leftovers or throwing away perfectly good food. It's about understanding that the way you reheat food matters just as much as the food itself. Small changes made consistently over many years can have a meaningful impact on your long-term health. The goal isn't perfection. It's making smarter choices that reduce unnecessary risks without making life more complicated. So here's the simple takeaway. Cool cooked food quickly and refrigerate it within an hour whenever possible. Avoid reheating leafy greens like spinach. Instead, enjoy them cold the next day. Store rice properly, eat it within 24 hours, and never reheat it more than once. When reheating meat or any cooked meal, use low heat with a splash of water or broth and a lid instead of blasting it in a hot, dry skillet. Stop reusing old frying oil, switch to a more stable cooking oil like extra virgin olive oil, and don't be afraid of your microwave. When used correctly, covered, stirred halfway through, and allowed to rest for a minute or two afterward, it is actually one of the safest and gentlest ways to reheat most foods, because it avoids the high surface temperatures that create many of the compounds we discussed today. One final reminder, if leftovers smell unusual, feel slimy, have changed color, or you honestly can't remember how long they've been sitting in the refrigerator, don't take the risk. No meal is worth gambling with your health. And if someone develops severe vomiting, persistent diarrhea, a high fever, blood in the stool, or signs of dehydration after eating reheated food, seek medical attention immediately. Foodborne illness can become serious very quickly, especially for older adults. Healthy aging isn't built on one miracle food or one magic supplement. It's built on hundreds of small decisions repeated every single day. The good news is that every tip you learned today is completely free, easy to apply, and can become a habit starting with your very next meal. If you found this information helpful, be sure to like this video, subscribe to the channel, and share it with someone who cooks for your family. A simple change in the kitchen today could protect the people you care about for years to come. Thank you for watching, take care of yourself, and I'll see you in the next video.